But when there's a big, deep disturbance down below a region, that region is disturbed by the deep disturbance, which is then causing all the activity as this wave comes up and spreads out from the deep disturbance that's happening below the plates. And then that'll get into where does the deep disturbance come from? And we can get into a lecture about the core of the Earth, VLF, ultra low frequency, extremely low frequency, plasmas and how they can generate those types of waves in the plates. And where do the plasmas come from? And where does the electricity that power it come from? But that's another discussion in another time. It comes from solar, by the way. In case you don't know, the charged particles from the sun and from space, but from charged particles from the sun, are absorbed by the Earth's magnetic field and taken down to ground. Ground isn't just ground below your house. Ground is the core of the Earth, and it's plasma at the core of the Earth. You may have heard that the core of the Earth is a solid ball of metal. That's what they used to think, because waves reflect off it like it's a solid and pass through it too. Pass through it and reflect off it as if it's a solid. But guess what else is reflective as if it's a solid and reflects shock waves, seismic waves, and radio waves? Plasma. The hidden secret of plasma will reflect shock waves. Boeing has actually patented the shockwave reflection device, and it's a arc generator. It generates a large lightning bolt, basically, but it goes out in a field around the Humvee vehicle or building, and it reflects the incoming shock waves from explosions. But it doesn't stop the shrapnel and the flying debris, but it stops the shock wave that will blow over a vehicle, and also, theoretically, they said could be used, if powerful enough, to deflect even a shock wave from a nuclear blast. But the invention idea is to stop shock waves from explosions from IEDs, improvised explosive devices. They patented it. It works. And so, how does it work? Well, the same principle applies to reflecting radio waves in the ionosphere using artificial ionospheric mirrors, plasma. HAARP, the other plasma-generating radio facilities, will generate plasmas in the atmosphere that reflect. And also, those plasmas generate very low frequency. That's how HAARP is able to generate very low frequency. In case you didn't know, the High Frequency Active Auroral Research Program project up in Alaska, the way that the high frequency generates low frequency. How do they do that? Well, they use high frequency to scuff its feet across the carpet of the atmosphere and build up an electrical charge. Simply put, high frequency scuffing its feet across the carpet of the ionosphere, and up in that area where they're targeting with the high power, radio waves, high frequency, it generates plasmas that are glowing air balls in the air that are huge, many kilometers wide, and it's visible actually on infrared. U.S. Navy has taken pictures of these. They generated above HAARP. And those plasmas are reflective to other radio waves, and they call it an artificial ionospheric mirror, simply called an AIM. And the AIMs are able to reflect all radio waves over the horizon and to somewhere else. So using high frequency, they can pulse up into the atmosphere or ionosphere and create a space mirror using electrons stripped from the radio waves themselves, targeted into a spot. That then can reflect radio waves of any kind, microwave and other, and it also vibrates like a bass speaker and generates its own very low frequency, ultra low frequency, extremely low frequencies, depending on how big they make the bass speaker. And the bass speaker is literally a giant ball of plasma in the atmosphere, many kilometers wide, generating that very low frequency radio wave comes out of it. And they can then bend it, twist it, turn it, and reflect the radio waves back down into the Earth, for instance. And this is not sci-fi. They've already done all these experiments. That's what I'm quoting to you, are the experiments from HAARP doing this. So why does it matter for in the ground? Well, guess what's at the core of the Earth? A more powerful version. Think of lightning. Where does lightning normally come from? Well, now you think it comes from the sky and strikes the ground, which it can and does. But most lightning comes from the ground and the magnetic potential between the ground and the sky. Right? But lightning comes up even further from down below. It comes up from deep down below in the crust. And that even comes up from further down below. It comes up from the core. Now, we're told the core is a solid ball of iron or nickel. And they thought it was because it got waves reflected off of it, and they thought it was solid. They didn't know that plasma reflected shock waves from earthquakes, shock waves from explosions, which is how they measured the core of the Earth. So now that we know that shock waves can be reflected from plasmas, it stands to reason that there's plasma in the core of the Earth. And that is strong enough to generate an electromagnetic field going far out in space, by the way. Plasmas generate large electromagnetic fields. So, back to it. The deep earthquakes. The deep earthquakes come up from deep down below, but they are caused by the disturbance or a vibration or an extremely low frequency coming up from the core. And it hits the undersides of the plates, which then comes up, spreads out into what we're seeing now. So let me just I know you just got mind-numbingly blinded by all that, but let me just quickly sum it up, guys. The core of the Earth vibrates like a giant bass speaker. It's powered by the sun, charged particles that are fed to the North and South Pole like being plugged into a wall. The plasma torch at the center of the Earth is hot enough to melt anything, generates a large electromagnetic field, and it sends very low frequency, ultra low frequency, extremely low frequency waves up to the underside of the plate into the asthenosphere, which is the semi-melted magma down below the plates. There impact occurs. The wave physically impacts the underside of the plate. Boom, deep earthquakes. Down below the plates where there shouldn't be any earthquakes. There's nothing to quake. It's melted, it's magma. We're getting earthquakes down there. Thousands of miles down, or well, hundreds of miles down, thousands of kilometers up to. And so something's going on down below the plates in the area that's melted, and that's the very low frequency coming up. When it comes up, it then hits the undersides of the plates and spreads out following those red lines that I showed you the whole update, which I'll show you again right now, one more time. When the deep earthquakes, which you can see here raised high off the planet, come up from down below, we have letter D's to signify where we expect them to happen, forecast-wise. So all of our deep earthquakes right on our letter D there. Other deep earthquake right in the middle of our letter D here. No coincidence. The D's don't move. So, back to it. Deep earthquakes down below Fiji. Deep earthquakes down below Indonesia. Look what they have in common. Both are on the edges of the plate boundaries. Something came up from down below Fiji. Something came up from down below Indonesia. What's right next to where it came up? The big blast. What's right next to our other deep earthquake from 10 days ago? Or well, now 14 days ago? Taiwan, big blast, big spread, all coming from our big deep 6.8. These are just deep 4s and deep 5s. So we had a big deep 6.8 down below here first, and that sent a huge disturbance up. It's now been 2.5 weeks of us breaking apart between Taiwan, between the big blast, now this. It's all caused by that deep earthquake activity that's coming up. And what's causing the deep earthquake activity? The core vibrating, sending it up. But what's causing the core to vibrate, send it up? A discharge of energy from the sun. Comes into the North Pole, South Pole. Charged particles, the air glow, the northern lights, the southern lights. That air glow, the northern lights, that's electricity in the sky. And it's in waves because that's the waves of the Earth itself, the electromagnetic field of the Earth. And it gets picked up, and that electrical energy doesn't just magically go away. It gets absorbed into the Earth's magnetic field and taken to ground to the core. And the alternating current, the AC radio waves that are everywhere, making that up, convert to DC power when it goes down into the core. Literally DC power, like the kind of power you'd use to power an electronic device. Did you know radio waves are AC? Did you know that? you know radio waves can be converted from AC to DC and used for power? Did you know you can convert a radio wave in something called a rectenna? Class, your homework is this. Anyone who's listening and wants to know about wireless power transmission using any kind of radio wave, from AM to FM to microwave, wireless power. You want to know how to do it? Search rectenna, RECTENNA. It's a rectifying antenna that rectifies radio waves into usable DC power. And you'll find the most amazing things that have been hidden from the general public. And yes, it has been hidden. If you want to start, you can go over to my channel on YouTube and search rectenna. You can start there if you really want to have some fun. Let's go over there and do that and show everybody what comes up. If I have my channel open, geez. Okay, rectenna, RECTENNA. What comes up? Wow, the NASA experiment where they used radar to transmit across over a mile's distance. Just a fraction, a portion of the radar, not even 10% of what the power of the radar is. Sent it across a whole valley, and at the other end, they got a bunch of little microwave antennas like what would be in your cell phone. And each microwave antenna, that like what would be in your cell phone, is wired to a little gallium arsenide diode and a low-pass filter. And the gallium arsenide diode converts the radio wave that hits the antenna into power, into DC. And the low-pass filter makes it usable so it's not just all over the place. Steady. So, go look it up. Have fun. Rectenna. And you can make these things yourself if you really wanted to. On that note, have fun. Always go and learn more, and I will play music for us. I'm going to save this as a video now on YouTube.